So in this video, I'm going to be working through Edexcel's A-Level Maths 2023 Paper 2. So this is a pure paper. Steadily getting used to the technology and Edexcel. So let's get on with it, shall we? So this is question number 1. f of x is equal to x cubed plus 2x squared, take away 8x plus 5. Part A, find f double prime of x. So we need to find the second derivative of f. So first derivative, f prime of x is equal to, now this is just a polynomial, so we can bring the power down to the front, take 1 from the power, 3x squared plus 4x, take away 8, and then the second derivative will be 6x plus 4. So B part 1, solve f double prime of x is equal to 0. So 6x plus 4 is equal to 0. Subtract 4 from both sides, divide through by 6. We're going to get minus 4/6 or minus 2/3. And then part 2, hence find the range of values of x for which f of x is concave. So f of x is concave when the second derivative is negative. So 6x plus 4 is negative. Subtract 4 from both sides, divide through by 6. So x is less than minus 2/3. And you could write that just as that inequality, or you could write it in interval notation, like so, or you could write it in set notation, x is less than, rather. Just going to go for equals there. Okay. So this is question number 2. A sequence u1, u2, u3 is defined by u1 is 35, un plus 1 is un plus 7 cosine of n pi over 2, take away 5 lots of minus 1 to the n. So A, part 1, show that u2 is equal to 40. Okay, so u2 is equal to, so we'll have u1 plus, so using this formula here, okay, the un plus 1 is 2, so n will be 1. So we have u1 plus 7 cosine of 1 times pi over 2. Take away 5 lots of minus 1 to the 1. Okay? Now, u1, remember, is 35. So, replace that with 35. And let's try that out. So 35, actually we don't need the calculator for that, do we? We can go straight in with that. 35 plus cosine of pi over 2 is 0, so 7 lots of 0. And then take away 5 lots of minus 1 to the 1, so that's plus 5. 35 plus 0 plus 5 is 40. Right, part 2. Find the value of u3 and the value of u4. So u3 is going to be equal to u2 plus 7 cosine of 2 pi over 2, take away 5 times minus 1 squared. Okay, so let's go to the calculator, shall we? Plus, so we've got 40 plus 7 cosine of pi, and then take away 5 lots of minus 1 to the power of 2. So we have 28. And then u4 will be 28 plus 7 cosine of 3 pi over 2, take away 5 lots of minus 1 cubed. So 28 plus 7 lots of cosine of 3 pi over 2, take away 5 lots of minus 1 cubed, and that's 33. Okay. So B, part 1. Given that the sequence is periodic with order 4, write down the value of u5. So u1, remember, was 35, u2 was 40, u3 is 28, u4 is 33, okay? So if it's got period 4, then that sequence must be repeating over and over again. So the next term must be 35. So u5 is 35. Part 2, find the value of the sum from r is 1 to 25 of ur. So the sum from r is 1 to 25 of the sequence. So we're going to have 35 plus 40 plus 28 plus 33, and then the next bit will be plus 35 plus 40 plus 28 plus 33, and then plus 35 plus 40 plus 28 plus 33, and so on and so forth. Now, how many times is that going to happen? Well, because we've got 25, okay, we're going from 1 to 25 terms, those 4 will repeat 6 times. 4 6s are 24. So we'll have that 6 times, but 4 lots of 6 is 24, so we've got that 1 left over, so the next term of the sequence would have been 35. So 35 plus 40 plus 28 plus 33 times by 6, add on the 35, is 851, and that's my answer. So this is question number 3. Given that log base 2 of x plus 3 plus log base 2 of x plus 10 is equal to 2 plus 2 log base 2 of x, part A, show that 3x squared take away 13x take away 30 is equal to 0. Okay, so the first thing that I would do is I would combine the logarithms on the left-hand side using the product rule. So that will be log base 2 of x plus 3, x plus 10. So they both have the same base, so you can bring them together as a product. Now the 2 in isolation is log base 2 of 2 squared. So that's log base 2 of 4. And the 2 in front of the log base 2x, that can be brought up to the power using the power rule. So that's log base 2 of x squared. Okay, so the left-hand side, we could multiply the brackets out and get x squared plus 13x plus 30. And on the right-hand side, we can use the product rule to bring those two together and have log base 2 of 4x squared. Now we can get rid of the logarithms, so x squared plus 13x plus 30 is equal to 4x squared. You can only do that once you have log of something equals log of something else and nothing else is going on. Okay, then you can remove the logs. So then we can subtract the x squared plus 13x plus 30 from both sides and get 0 is equal to 3x squared, take away 13x, take away 30, and so let's make sure we've got it written as it appears. As required. Okay, so B part 1. Write down the roots of the equation 3x squared take away 13x take away 30 equals 0. Okay, so I'm going to go to my quadratic solver. Let's type it in. 3x squared take away 13x take away 30 equals 0. And we get minus 5/3 and 6. So what I'm going to do is I'm going to write it in factorized form. 3x plus 5, x take away 6 equals 0. So that implies that x is equal to minus 5/3, or x is 6. Okay, so always good practice to write it in factorized form as you go, if you can. Part 2, hence state which of the roots in part B, part 1 is not a solution of log base 2 of x plus 3 plus log base 2 of x plus 10 equals 2 plus 2 log 2x, giving a reason for your answer. Well, we can't have x equals minus 5/3, can we? So x cannot be equal to minus 5/3, and the reason for that is because you can't substitute minus 5/3 into here, your right-hand side, because you won't get a real solution, as log base 2 of minus 5/3 is not real. Okay? And so, that is my answer to question number 3. So this is question number 4. Coffee is poured into a cup. The temperature of the coffee, H degrees Celsius, T minutes after being poured into the cup, is modeled by the equation H equals AE to the minus BT plus 30, where A and B are constants. Initially, the temperature of the coffee was 85 degrees Celsius. Part A. State the value of A. So we know that initially, so when T is 0, H is 85. So 85 is equal to AE to the minus B times 0 plus 30. Now, B times 0 is of course 0, so e to the 0 is 1. So 85 is equal to A plus 30. And so A would have to be 55. Initially, the coffee was cooling at a rate of 7.5 degrees Celsius per minute. Find a complete equation linking H and T, giving the value of B to 3 decimal places. Let's write out what we've got so far. H is equal to 55 e to the minus bt plus 30. Now, because we're talking about it cooling at a rate, that means we need to find the derivative, dH by dt. So dH by dt is equal to, now differentiating this, we're going to have the coefficient of t come down to the front, so minus b comes to the front, so minus 55 b e to the minus bt, and the 30 differentiates to 0. Okay, we know that initially, okay, the rate is it's cooling at 7.5 degrees Celsius per minute, so that means it is negative 7.5. So if I substitute t equals 0 into our derivative and put it equal to minus 7.5, this gives us this equation. Now, minus b times 0 is still 0, e to the 0 is still 1, so b is minus 7.5 over minus 55, or 7.5 over 55. Now, what's that? That's 3 over 22, which is 0.136 to 3 decimal places. Okay, now it says find a complete equation, so that means we need to write our finished equation. H is equal to 55 e to the minus 0.136t plus 30. And so that's our equation, as required. So this is question number 5. The curve C has equation y equals f of x. The curve passes through the point P, 3 minus 10, and has a turning point at P. Given that dy by dx is 2x cubed, take away 9x squared plus 5x plus k, where k is a constant. Part A, show that k is equal to 12. Okay, so we know that there is a turning point at P, so that's when x is equal to 3, okay, given the fact that we've got the coordinates of P there. So, if I substitute 3 into dy by dx, I should get 0. So, 2 times 3 cubed, take away 9 lots of 3 squared, plus 5 lots of 3, plus k is equal to 0. So we have two lots of 3 cubed, so that's 54. 9 times 9 is 81, plus 15, plus k equals 0. 54, take away 81, plus 15 is minus 12. So k equals 12 as required. Right. Part B. Hence find the coordinates of the point where C crosses the y-axis. So that means we need to integrate to find the equation of the curve. So y will be equal to, so integrating, it's a polynomial, so we add 1 to the power, divide by the new power, so 2x to the 4 over 4, take away 9x cubed over 3, plus 5x squared over 2. Now the k we know is 12, so that's going to integrate to 12x, and we're going to have a plus c constant of integration. Okay, let's simplify this. So y is equal to 1/2 x to the 4, take away 3x cubed, plus 5/2 x squared, plus 12x, plus c. So we need to work out c. Now, the point P has coordinates 3 minus 10. So that's now what we're going to substitute in. So the y is minus 10 and the x is 3. So 1/2 times 3 to the 4, take away 3 times 3 cubed, plus 5/2 times 3 squared, plus 12 lots of 3, plus c. So we have 1/2 times 3 to the 4, take away 3 lots of 3 cubed, plus 5/2 of 3 squared, plus 12 lots of 3. That's 18, plus c, and so c must be minus 28, subtracting 18 from both sides. So therefore, so c crosses the y-axis at 0 minus 28. So this is question number 6. Relative to a fixed origin O, A is the point with position vector 12i, B is the point with position vector 16j, C is the point with position vector 50i plus 136j, D is the point with position vector 22i plus 24j. Part A. Show that AD is parallel to BC. So we need to find the vector AD. Now the vector AD is OD minus OA. Now OD is 22i plus 24j, and we're subtracting OA, which is 12i. So that will leave us with 10i plus 24j. Now we also need to find BC, so BC is OC minus OB. Now OC is 50i plus 136j, and OB is 16j. So we have 50i, 136 take away 16 is 120. Okay, so comparing those two, you can see that BC is 5 lots of AD. So BC is 5 lots of AD. So AD is parallel to BC as required. Okay. So part B. Points A, B, C and D are used to model the vertices of a running track in the shape of a quadrilateral. Runners complete one lap by running along all four sides of the track. The length of the sides are measured in meters. Given that a particular runner takes exactly 5 minutes to complete 2 laps, calculate the average speed of this runner, giving the answer in kilometers per hour. Okay, so the idea here is that you have a quadrilateral. Don't know what it really looks like. This isn't trying to draw it accurately. Okay, here's A, B, C, D. Okay, so what we need to do is we need to go, well, we need to figure out AB, BC, CD, DA. Okay, if I work out those lengths, I can double it and then figure out how fast it would take to get around there in 5 minutes. Okay, so I already have AD, so I've got that side fixed, and I've got BC, I've got that side fixed. Okay, so I need to find AB and CD. So AB is going to be equal to OB minus OA. So OB is 16J and OA is 12I. So that's minus 12I plus 16J. Okay, now I need to find CD. So that's OD minus OC. Now OD, 22I plus 24J. Take away OC, which is 50I plus 136J. Okay, so 22, take away 50, so minus 28I. Then we've got 24, take away 136, so that's minus 112J. Okay, so the length of A to B, using Pythagoras, will be the square root of minus 12 squared plus 16 squared, square rooted. So 12 squared plus 16 squared is 400, square root of that is 20. We need the length of BC, which is the square root of 50 squared plus 120 squared. So 50 squared plus 120 squared is 16900. Square root of that is 130. We need the length of CD. So I'm going AB, BC, CD. So we've got square root of minus 28 squared plus minus 112 squared. Now that's 13328, so square root of that is 28 root 17. And then finally, from D back to A. Now we found AD, so DA will be minus 10I, take away 24J. So minus 10 squared plus minus 24 squared. Doesn't really matter if you've got the minus signs there. The length of the vector will be the same regardless. So that's root 676 is 26. Okay, so 1 lap in meters is the sum of all those lengths. So 20 plus 130 plus 28 root 17 plus 26 is 176 plus 28 root 17. So 2 laps will be 352 plus 56 root 17. Now remember, this is in meters, okay? We want to calculate the average speed of the runner in kilometers per hour. So the speed will be equal to. Now we need to do 352 plus 56 root 17. So that's meters. So divide that by 1,000 to turn it into kilometers. And if we remember, the runner took 5 minutes to complete 2 laps. Okay, so 5 minutes, we want that in hours, so that's 1/12 of an hour. So we need essentially your 5 minutes divided by 60 to turn it into hours. So let's figure out what that is. So that divided by 1,000, and then divided by 5 divided by 60, or 1/12, and we get 6.99472,698. So 6.99 kilometers per hour to 3 significant figures. So this is question number 7, and in big bold writing at the start, in this question you must show all stages of your working. Solutions relying on calculator technology are not acceptable. A curve has equation x cubed plus 2xy plus 3y squared equals 47. Part A, find dy by dx in terms of x and y. So we are going to be differentiating both sides with respect to x. So d by dx of x cubed plus 2xy plus 3y squared is equal to d by dx of the right hand side, so 47. So differentiating x cubed with respect to x gets us 3x squared. Now differentiating 2xy, we're going to have to do that using the product rule. So we've got 2x times y. So 2x times the derivative of y is 2x dy by dx, plus y times the derivative of 2x, so 2y. And then you've got 3y squared, which differentiates to 6y, stick a dy by dx on the end. And then the right-hand side differentiates to 0. So we've got 2 terms with dy by dx on the left-hand side. Let's factorise that. So 2x plus 6y, dy by dx. And move the other terms, so minus 3x squared and minus 2y onto the right-hand side. So if we divide both sides by the bracket, what I can also do is I can bring the minus sign outside of the fraction and have minus 3x squared plus 2y over 2x plus 6y. Okay, so that's what we needed for part A. The point P, minus 2, 5, lies on the curve. Find the equation of the normal to the curve at P, giving your answer in the form ax plus by plus c equals 0, where a, b and c are integers to be found. Okay, so I need to substitute point P, so minus 2, 5, into the dy by dx. So that's minus 3 lots of minus 2 squared plus 2 lots of 5 over 2 lots of negative 2 plus 6 lots of 5. So what have we got? Minus 3 lots of 4 plus 2 lots of 5 over 2 lots of minus 2 plus 30. So that's minus 11/13. So that's the gradient of the tangent. So the normal has the equation y minus y1, so y minus 5, is equal to the negative reciprocal of minus 11/13, so 13/11, x minus x1, so x plus 2. Now we need it in this specific form, so let's get rid of the fraction by multiplying through by 11 now. So 11y minus 55, and multiply out the brackets, 13x plus 26. Then subtract 13x from both sides, and subtract 26 from both sides. So minus 81 is equal to 0. And if you prefer, you could write that in that form instead, multiplying through by -1. So this is question number 8. Part A, express 2 cosine theta plus 8 sine theta in the form r cosine theta take away alpha, where r and alpha are constants, r is greater than 0, and alpha is between 0 and pi over 2, so alpha is an acute angle. Give the exact value of r and give the value of alpha in radians to 3 decimal places. Okay, so part A, 2 cosine theta plus 8 sine theta is equivalent to r, oops, daisy, let's try that again, r cosine of theta minus alpha. So using the compound angle formulae, that would be r cosine theta cosine alpha plus sine theta sine alpha. Now if you expand the bracket out, bring the alphas to the front, so r cosine alpha cosine theta plus r sine alpha sine theta. So whatever's in front of the cosine theta here must be whatever's in front of the cosine theta here, so that's r cosine alpha must be 2, and whatever's in front of the sine theta here must be whatever's in front of the sine theta here, so r sine alpha must be 8. So cosine alpha is 2 over r, sine alpha is 8 over r. Let's draw ourselves a right angle triangle. Here's alpha. And if cosine alpha is 2 over r, that's the adjacent over the hypotenuse, so 2 over r. And sine is opposite over hypotenuse, so the opposite side must be 8. So r is the square root of 2 squared plus 8 squared. So 2 squared plus 8 squared is 68. Square root of 68 is 2 root 17. And alpha is arctan of 8 over 2. So arctan of 4. Make sure you're in radians. And that is to 3 decimal places, 1.326. Okay, so therefore 2 cosine theta plus 8 sine theta is equivalent to 2 root 17 cosine of theta take away 1.326. Okay, so that's part A. Now, the first 3 terms of an arithmetic sequence are cosine x plus sine x, cosine x plus 2 sine x, where x is not equal to n pi. Given that S9 represents the sum of the first 9 terms of this sequence as x varies, so B part 1, find the exact maximum value of S9. Okay, so let's first of all work out what S9 is. So we've been told that it's an arithmetic sequence, and it is arithmetic because we've got this first term cosine x, and each time you're adding on a sine x. Okay, so that's your common difference. So the sum of the first 9 terms using the formula is 1/2 times n times by 2 lots of a, so 2 lots of cosine x, plus n minus 1, so 8, times the common difference, which is sine x. Okay, so we've got 1/2 times 9 times 2 cosine x plus 8 sine x. Now, doesn't that look similar to you? The 2 cosine x plus 8 sine x is what we were just working with in part A. So this is 9/2 times by 2 root 17 cosine of x take away 1.326. Okay, so the max value of S9 is 9 halves times by the maximum value of 2 root 17 cosine x take away 1.326, which is 2 root 17. That 2 root 17 means that the cosine curve is going between minus 2 root 17 and positive 2 root 17, because cosine goes between minus 1 and 1. So 2 root 17, which is equal to 9 root 17. So that's the maximum value. Part 2, deduce the smallest positive value of x at which this maximum value of S9 occurs. Okay, so we need the 9 halves times 2 root 17 cosine of x take away 1.326. So we need this, so 9 root 17 cosine of x take away 1.326 to be equal to 9 root 17. Okay, so what we need is cosine of x take away 1.326 to be equal to 1. Okay, so the cosine curve looks like this. And so is at its maximum value at 0 and then at 2 pi. Okay. So essentially, I'm going to put the x take away 1.326 equal to 0. Okay, because cosine of 0 is 1. So that means that x is 1.326. And so that is the smallest positive value of x at which the maximum occurs. So this is question number 9. The curve C has parametric equations. X equals t squared plus 6t take away 16. Y equals 6 natural log of t plus 3, where t is greater than minus 3. So part A. Show that a Cartesian equation for C is y equals a log x plus b, where x is greater than minus b, where a and b are integers to be found. Okay. So how am I going to get there? So I guess what I need, because it's y equals, I need to get t in terms of x. So I'm going to have to start with x equals t squared plus 6t take away 16. Let's rearrange this to get 0 equals t squared plus 6t take away 16 take away x. Right, I'm going to complete the square on the right hand side. So 0 equals t plus 3 squared, take away 3 squared, so take away 9, and we've already got the take away 16, take away x there. So 0 equals t plus 3 squared, take away 25, take away x. So t plus 3 squared is got to be 25 plus x. So t plus 3 must be equal to plus or minus the square root of 25 plus x. So t is equal to negative 3 plus or minus the square root of, let's write it that around this way, x plus 25. Now, because we're told that t's got to be greater than negative 3, that means that t equals minus 3 take away square root of x plus 25 isn't right, okay, because you'd be subtracting a positive value away from the negative value already there, so that's definitely not right. So as, oops daisy, let's try again, as t is greater than negative 3, we must have t equals negative 3 plus the square root of x plus 25. Okay, so then I need to substitute that into the y. So therefore, y equals 6 times the natural log of minus 3 plus the square root of x plus 25 plus 3. So we can see that the 3's cancel away. And x plus 25 square rooted is x plus 25 to the half. So then we can use the power rule to bring that half down to the front. And then we've got it in the required form. So A is 3 and B is 25. Okay. Right, part B. The curve C cuts the y-axis at the point P. Show that the equation of the tangent to C at P can be written in the form ax plus by equals c log 5, where a, b and c are integers to be found. Okay, so if it cuts the y-axis at the point P, then that must mean when x is 0. So 0 equals t squared plus 6t take away 16. So that factorises to t plus 8, t take away 2. So t must be equal to 2, as t, remember, was greater than minus 3. So we can't have t as negative 8. Okay? So we've got t equals 2. So then I could work out the y value when t is equal to 2. So that was 6 times the natural log. What was it? Let's have a look. 6 times the natural log of t plus 3. So 2 plus 3. So that's 6 log 5. Okay. So we now have the coordinates of P. So therefore, P has the coordinates 0, 6 log 5. Now, we're looking for the equation of the tangent, so we're going to have to find dy by dx. Okay, so dy by dx is dy by dt over dx by dt. Now, y was equal to 6 log x plus 5. So that differentiates to 6 over x plus 5. Sorry, t plus 5. It was t, wasn't it? Oh, 6 log t plus 3. Right, let's try that again. 6 log t plus 3. I apologise. There we go. It's difficult when you can't see it on the same screen. Right, so y equals 6 natural log of t plus 3 differentiates to 6 over t plus 3. Okay, using the chain rule. So x, that differentiates with respect to t to 2t plus 6. So 2t plus 6. Now 2t plus 6 is 2 lots of t plus 3. So we've actually got 6 over t plus 3 divided by 2 lots of t plus 3. So we do 6 divided by 2 is 3, and we're going to have t plus 3 squared. So dy by dx when t is 2 is 3 over 2 plus 3 squared. So that's 3 over 25. So the tangent, using y minus y1 equals mx minus x1, will be y take away 6 log 5 is equal to m, 3 over 25, times x take away x1, which is x take away 0. So if I multiply everything through by 25, 25y, take away 150 log 5 is equal to 3x. So minus 3x plus 25y is equal to 150 log 5. And that was the format that they wanted it in. ax plus by equals c log 5, where a, b and c are integers to be found. So a is negative 3, b is 25, and c is 150. So this is question number 10. F of x is equal to 3kx take away 18 over x plus 4x take away 2, where k is a positive constant. Part A, express f of x in partial fractions in terms of k. Right, part A. So 3kx take away 18 over x plus 4 x take away 2. So the partial fractions form will be a over x plus 4 plus b over x take away 2. So if we multiply both sides by x plus 4 x take away 2, we'll get 3kx take away 18 is equivalent to a x take away 2 plus b x plus 4. So if we start substituting values in, let's first let x be 2. Then the left-hand side will be 3k times 2, so 6k, take away 18. On the right-hand side, it'll knock out that bracket by design, and we'll have 6b. So b is going to be k take away 3. Now, if we let x instead be negative 4, the left-hand side will be 3k times negative 4, so minus 12k, take away 18. And on the right-hand side, we'll have negative 4, take away 2, so minus 6a, and that bracket will be 0. So a, dividing through by minus 6, will be 2k plus 3. So therefore, f of x is equal to 2k plus 3 over x plus 4 plus k take away 3 over x take away 2. Okay, that's the partial fractions bit done. Part B, hence find the exact value of k for which the integral of fx dx is 21, integrated between minus 3 and 1. So we want the integral between minus 3 and 1 of 2k plus 3 over x plus 4 plus k take away 3 over x take away 2 dx to be 21. Okay, so let's integrate. So 2k plus 3 over x plus 4. The 2k plus 3 is just a constant term, okay? It's just a constant, just a number. So if you've got 1 over x plus 4, that integrates to the natural log of the modulus of x plus 4. So we'll have 2k plus 3 times by the natural log of the modulus of x plus 4. And likewise, plus k take away 3 times the natural log of the modulus of x take away 2. Evaluated between minus 3 and 1, and that's got to be equal to 21. So let's start substituting our limits in. So substituting in 1, we're going to get 2k plus 3 times the natural log of modulus of 1 plus 4, so log 5, plus, now substituting 1 into this, we're going to get the natural log of the modulus of 1 take away 2, which is the natural log of the modulus of minus 1, which is natural log of 1, which is 0. So actually you get k take away 3 times the natural log of 1, and of course that is just going to be 0. Okay, so that's going to go. Right, take away, substituting minus 3 now. 2k plus 3 times the natural logarithm of minus 3 plus 4 is negative 1, modulus that is 1. So that term will also be 0. I wouldn't use a highlighter in the exam, okay? Don't put a line through it either. Just on the next line, evaluate it to 0, okay? Plus, substituting minus 3 into the second term, k take away 3, natural log of, minus 3 take away 2 is minus 5, modulus of that is 5, and that's going to be equal to 21. Okay, so what do we have? We've got 2k plus 3, natural log of 5, take away k take away 3, natural log of 5 is equal to 21. So if we divide through by log 5, we get 2k plus 3, take away k plus 3 is equal to 21 over log 5. So we have k plus 6 is 21 over log 5. So k is 21 over log 5, take away 6. And that's my answer. So this is question number 11. And once again, this is another one of those questions where Edexcel has completely filled the page. So they haven't thought about YouTubers trying to go through their papers, have they? Makes it very difficult. Okay, right, so question number 11. A tank in the shape of a cuboid is being filled with water. The base of the tank measures 20 metres by 10 metres and the height of the tank is 5 metres, as shown in figure 1. At time t minutes after water started flowing into the tank, the height of the water was h metres and the volume of water in the tank was v metres cubed, or v cubic metres. In a model of this situation, the sides of the tank have negligible thickness. The rate of change of v is inversely proportional to the square root of h. Part A, show that dh by dt is lambda over the square root of h, where lambda is a constant. Okay, so let's find ourselves a little bit of space here. So first of all, a couple of thoughts. We can identify the amount of water that's in the tank. So V as being 20 times 10 times h, right? So that's 200h. So part A, V equals 200h. Now, what else have we got? We're told that the rate of change of V is inversely proportional to the square root of h. So that means that dv by dt is k over the square root of h. So the rate of change of v with respect to time is inversely proportional to the square root of h. So dv by dt, by dt is k over root h. Okay, so we've got those two bits of information. So let's just go back up to what we need to find. So it's saying, show that dh by dt is lambda over root h. Now the key thing here is that we want dh by dt, and so far we've got dv by dt. So there's a bit of connected rates of change here. Okay, so because we want dh by dt, that's going to be dh by dv times dv by dt. I've got the dv by dt already, but I don't have dh by dv. So if I differentiate v with respect to h, I get 200. So dh by dv is 1 over 200 times k over root h. So we have k over 200 root h, and that is my lambda over 200, sorry, not over 200, over root h. Where lambda is k over 200. Okay, and so that is the format that I needed. Right, okay, go to part B. Given that initially the height of the water in the tank was 1.44 meters, so let's put that on. So T is 0, H is 1.44. And exactly 8 minutes after water started flowing into the tank, the height of the water was 3.24. So when T is 8, H is 3.24. Okay. Use the model to find an equation linking H with T, giving your answer in the form of H to the 3 halves is equal to A T plus B, where A and B are constants to be found. Okay, so we have dH by dt is lambda over root h, or h to the half. So we need to solve this differential equation. So first of all, we need to separate the variables. So I'm going to multiply up by h to the half and multiply up by the dt. So we're going to have the integral of h to the half dh is equal to the integral of lambda dt. Now, h to the half integrates to add 1 to the power divided by the new power. So 2/3 h to the 3 halves. And on the right hand side, lambda is just a constant, so that's going to integrate to lambda t plus a constant of integration. So you're going to put the constant of integration on the right hand side as we traditionally do. And I've got those 2 bits of information that's going to allow me to work out lambda and t now. Sorry, lambda and c. So first of all, t is 0, h is 1.44. So 2/3 of 1.44 to the 3 halves is equal to lambda times 0 plus c. So 2/3 times 1.44 to the 3 halves is 1.152. And if I now substitute in t is 8, h is 3.24, so we've got lambda times 8, so 8 lambda. And I've just worked out c. So we're going to have 2/3 times 3.24 to the 3 halves. Take away 1.152 divided by 8. And that's 0.342. So we have 2/3 h to the 3 halves is equal to 0.342 times t plus c, which is 1.152. Still not quite in the format they wanted, so I've got to multiply both sides by 3 halves. So 3 halves times 0.342 is 0.513. And 3 halves times 1.152, 1.728. Okay. Hence find the time taken from when water started flowing into the tank for the tank to be completely full. So if we go back to our diagram, the water's completely full when we've reached that 5 meters. So h needs to be 5 meters. So max when h is 5. So 5 to the 3 halves is equal to 0.513t plus 1.728. So 5 to the 3 halves. Take away 1.728 divided by 0.513. So t is 18.4256, etc. So 18.4 minutes to 3 significant figures. And that's my answer. So this is question number 12. We have been given figure 2. The number of subscribers to 2 different music streaming companies is being monitored. The number of subscribers, NA, in thousands to company A, is modelled by the equation NA equals T take away 3 modded plus 4, where T is equal to 0, where T is the time in years since monitoring began. The number of subscribers, NB, in thousands to company B, is modelled by the equation NB is 8 take away the modulus of 2T take away 6, where T is equal to 0, where T is the time in years since monitoring began. Figure 2 shows a sketch of the graph of NA and the graph of NB over a 5-year period. Use the equations of the models to answer parts A, B, C, and D. Find the initial difference between the number of subscribers to company A and the number of subscribers to company B. Right, well, once again, Edexcel has filled up the page, so I'm going to have to go over to the other page and keep flipping back and forth. So part A, first of all, I'm going to rewrite the equations. So NA was T take away 3 modded plus 4. And NB was 8 take away the modulus of 2T take away 6. Okay, so part A. Let's just remind ourselves. Find the initial difference between the number of subscribers to company A and the number of subscribers to company B. So, when T equals 0, NA will be 0 take away 3 plus 4. So the modulus of negative 3 is 3, plus 4 is 7. And for NB, we'll have 8 take away the modulus of 2 times 0 take away 6. Well, the modulus of minus 6 is 6. 8 take away 6 is 2. So initial number of subscribers, difference will be, we've got 7,000, take away 2,000, and so that's 5,000. Okay, right, part B. When T is equal to capital T, company A reduced its subscription prices and the number of subscribers increased. Suggest a value for capital T, giving a reason for your answer. Okay, so we're looking at NA here. So you can see that the number of subscribers decreased, and then it hit an all-time low, and then it started to increase again. So the point at which it starts to increase, that will be the capital T that I'm looking for. So that is the vertex of that graph. So the number of subscribers will be at its minimum. Let's try that again. At its minimum when the modulus of T take away 3 is 0, okay, because the modulus of T take away 3 will be greater than or equal to 0, and so 4 will be the minimum, and then it'll increase from there on. So that will happen when T is equal to 3. So capital T equals 3, and the number of subscribers will increase after this. Okay, so part C, find the range of values of t for which NA is greater than NB, giving your answer in set notation. Okay, so what I'm going to do is I'm going to create a small little copy of that diagram so we can visualize what's going on here. So the graph kind of looks something like this. And then something like that. Okay, so this is NA, and that's NB. So let's say we want to work out this intersection point first. So that is the intersection when NA has positive gradient. So that means you need the coefficient of t to be positive. So you remove the modular signs, so ignore the modular signs, and you want the coefficient of t to be positive. So for NA, it will be t take away 3 plus 4. So that is that part of the graph, the positive part. So let's make sure that's highlighted. Okay, and that's going to be equal to the negative gradient part of NB. So ignoring the minus sign, modular signs rather, you want to keep the negative sign in front of the coefficient of t. So 8 take away 2t take away 6. So let's simplify this. So t plus 1 minus 3 plus 4 is equal to 8 take away minus 6, so 14 take away 2t. Add the 2t to both sides, so 3t. Subtract 1 from both sides, and then t will be 13 thirds. And so that point is 13 thirds. And now we want to work out the other intersection point. So that is when the NA is negative, so you've got negative gradient, so you want a minus sign in front of the t take away 3 plus 4, and the NB is positive, so you want 8 plus 2t minus 6. Okay, so minus t plus 3 plus 4 is 8 plus 2t take away 6. So we've got minus t plus 7 is equal to 2 plus 2t. So 3t will be equal to 5. So t will be equal to 5 thirds. So that's that point there. So NA is greater than NB here for that region and for that region. So we want this in, what did the question ask? Find the range of values for t for which NA is greater than NB, giving your answer in set notation. Okay, so we need it to be t is such that t belongs to the real numbers. Now, will it accept t is less than 5 thirds, but t is greater than or equal to 0? So I think we should probably have 0 is less than or equal to t is less than 5 thirds. Then union, t is such that t belongs to the real numbers, and then t is greater than 13 thirds, but then it's going up to 5, isn't it? So I'm assuming 13 thirds is less than t is less than or equal to 5 as the endpoints. Okay, let's have a quick look at the mark scheme, just to make doubly sure of this. So they don't have the 0 or the 5. Let's just look at the extra guidance. So this was part C. Oh, here you go. Note that a lower bound for t is less than 5/3 and an upper bound for t is greater than 13/3 are not required, but may be included. Okay. Fine. Fine. Okay. So, yeah. Right. Part D then. State a limitation of the model used for company B. So specifically company B. Well, company B, if it continues on its trajectory, is going to continue to decrease even beyond and goes into negative number of subscribers. So the equation was 8 take away the modulus of 2t take away 6. So a limitation for the model for company B is that eventually the model predicts a negative number of subscribers. So, can we work that out? So if you just look at the negative part of the graph, so 8 take away 2t take away 6, and you put that equal to 0, then add that to both sides, add 6 to both sides, so 2t is 14, so t is 7. So i.e. in year 7 there will be 0 subscribers. Okay, and then it would continue to decrease, which is unphysical. So this is question number 13, and in big bold writing at the start, in this question you must show all stages of your working. Solutions relying entirely on calculated technology are not acceptable. You have been warned. So, part A, find the first 3 terms and ascending powers of x of the binomial expansion of 3 plus x to the minus 2, writing each term in simplest form. Okay, so part A, 3 plus x to the minus 2. Now, we can't do anything with this. We can't go straight to the formula because it's not 1 plus or 1 minus inside the bracket. So, the first thing we need to do is make it into that format. So we're going to factor the 3 out of the 2 terms inside the bracket. So 1 plus x over 3 to the minus 2. And now you've got 3 to the minus 2, which is 1/9. 1 plus x over 3 to the minus 2. Now we're ready to use the formula. So this is going to be equal to 1/9 times. Now the formula goes 1 plus n times x, so minus 2 times x over 3, plus n times n minus 1 over 2 factorial, then x squared, so x over 3 squared, plus a load of other terms I'm not interested in because I want the first 3 terms. Okay, so this is going to be equal to 1/9 times by 1 take away 2/3 x, and then let's simplify this. So minus 2 times minus 3 divided by 2 factorial times by 1/3 squared is 1/3. So plus 1/3 x squared. And now we can multiply through by the 1/9. So we get 1/9 take away 2 over 27x plus 1 over 27x squared, etc. Okay? So part B. Using the answer to part A and using algebraic integration, estimate the value of the integral between 0.2 and 0.4 of 6x over 3 plus x all squared dx, giving your answer to 4 significant figures. Okay, so we have the integral between 0.2 and 0.4. Now, the 6x over 3 plus x squared, I can write as 6x times 3 plus x to the minus 2. And so that should now be clear as to where we're going with this. So the 6x, actually, I won't put that as equal to. This is approximately equal to. So 6x times 1/9, take away 2 over 27x, plus 1 over 27x squared, dx. Okay, now I need to multiply this out. So 6 over 9 is 2/3, so 2/3 x. Then we've got 6 times 2 over 27, so 4/9. So take away 4/9 x squared. And then 6 over 27 is 2/9, so plus 2/9 x cubed dx. Right. Now we actually integrate. So adding 1 to the power divided by the new power, so 1/3 x squared. Then take away 4 over 27 x cubed. And then, what's that, 1/9, 1/18 x to the 4, evaluated between 0.2 and 0.4. Okay. So, now I need to substitute in the 0.4. Now, because we had that big bold bit at the beginning showing all your working, I'm actually going to show the substitution here. So, 1/3 times 0.4 squared, take away 4 over 27 times 0.4 cubed, plus 1 over 18 times 0.4 to the 4, take away 1/3 times 0.2 squared, take away 4 over 27 times 0.2 cubed, plus 1 over 18 times 0.2 to the 4. Right, let's work out what these are. So 1/3 times 0.4 squared, take away 4 over 27 times 0.4 cubed, plus 1 over 18 times 0.4 to the 4. So this is 764 over 16,875. And if I replace all those 0.4s with 0.2s, we get 413 over 33,750. If we do that one, take away that one, we get 223 over 6,750, which to 4 significant figures is 0.03304. Okay. Right, part C. Find, using algebraic integration, the exact value of the integral between 0.2 and 0.4 of 6x over 3 plus x squared dx, giving your answer in the form a log b plus c, where a, b and c are constants to be found. Okay, so part C. The integral between 0.2 and 0.4 of 6x over 3 plus x squared, wasn't it? Right. Okay, so method for this would be integration by substitution. That would be what I would choose. The way I'm identifying that is that I know that if I make the substitution, u is 3 plus x, then I'm going to just have a single term in the denominator. Then I'm going to be able to simplify the fraction, integrate the individual pieces. So I'm thinking a couple of steps ahead. So once you've got your substitution, first thing to do, differentiate it. So du by dx is 1. So du will be equal to dx. Okay, so we've got the replacement for dx. We need to change the limits. So when x is 0.4, you substitute it back into the substitution. So 3 plus 0.4, 3.4. And when x is 0.2, u will be 3 plus 0.2, so 3.2. Okay, so I've got replacement for everything apart from that 6x now. So go back to the substitution, get x as u take away 3, and so 6x multiplying both sides by 6 is 6u take away 18. So we have the integral between 3.2 and 3.4 of 6u take away 18 over u squared du. So this is precisely the stage that I was considering, because I can now split that fraction up into two terms. 6u over u squared is 6 over u. Take away 18 over u squared, so 18u to the minus 2. Now we can integrate. So 6 over u integrates to 6 times the natural log of the modulus of u. And then minus 18u to the minus 2, add 1 to the power, divide by the new power, plus 18u to the minus 1. Integrate between 3.2 and 3.4. Okay, actually let's go down here where we've got some space now. So substituting in 3.4, 6 times the natural log of 3.4 plus 18 times 3.4 to the minus 1. Then substituting 3.2, so 6 log 3.2 plus 18 times 3.2 to the minus 1. I think I'll put those in brackets. There we go. So we have 6 times the natural log of 3.4. Then we've got this 18 times 3.4 to the minus 1, which is 90 over 17. Take away 6 times the natural log of 3.2, get rid of the bracket. And then we've got 18 times 3.2 to the power of minus 1, which is 45 over 8. So the two logarithms, they can be combined to make 6 times the natural log of 3.4 over 3.2 using the quotient rule for logarithms, that is. And then you've got the 90 over 17, take away 45 over 8. So take away 45 over 136. So 3.4 over 3.2 is 17 over 16. Okay, and so that is the answer in the format that we wanted. So this is question number 14, and in bold again, in this question you must show all stages of your working. Solutions relying entirely on calculated technology are not acceptable. So, part A, show that the equation 2 tan theta 8 cosine theta plus 23 sine squared theta is equal to 8 sine 2 theta 1 plus tan squared theta may be written as sine 2 theta a cosine squared theta plus b cosine theta plus c equals 0, where a, b and c are constants to be found. Okay. Right, now, the first thing to note is, in the format that they want us to get it in, there's the sine 2 theta factorised out. On the right-hand side of the equation is already a sine 2 theta. So I don't think I want to mess with that. I'm going to leave that exactly where it is. But there's a few other things I can do. I definitely don't want tan thetas there, okay? And I don't want sine thetas there. So, on the left-hand side, you've got 2 tan theta. So I can write that as 2 sine theta over cosine theta. Open up a bracket, 8 cosine theta, and the 23 sine squared I can replace with 23 lots of 1 minus cosine squared, because sine squared plus cos squared is 1. And leave the sine 2 theta as it is. And the 1 plus tan squared is sec squared. That's one of the trig identities that you need to know. Okay? Right, now, sec squared, of course, is 1 over cosine squared. So if I multiply both sides by cosine squared, then one of the cosines is going to get knocked out by that 2 sine theta over cosine theta, and I'm going to get left with 2 sine theta cosine theta, 8 cosine theta, multiply out the bracket, 23, take away 23 cosine squared theta is equal to 8 sine 2 theta. Okay. Now, the good news is that on the left-hand side, you've got 2 sine theta cos theta, which is the double angle formula sine 2 theta. So that's just what we wanted. So that's sine 2 theta. So let's rearrange the terms in here. So take away 23 cosine squared theta plus 8 cosine theta plus 23. Take 8 sine 2 theta from both sides. And now we can factorise. So factoring sine 2 theta out, we'll have minus 23 cosine squared theta plus 8 cosine theta plus 23. Now take away 8 as well. And so we have sine 2 theta minus 23 cosine squared theta plus 8 cosine theta, and then plus 15 equals 0. Now, you can either leave it like that, or we can multiply through by minus 1 and have 23 cosine squared theta minus 8 cosine theta minus 15 equals 0. Okay? Right, part B. Hence, solve for 360 degrees to 540 degrees inclusive. 2 tan x, 8 cosine x plus 23 sine squared x equals 8 sine 2x, 1 plus tan squared x, where x is a real number and x is not equal to 450 degrees. Okay, so comparing these two, okay, everything looks the same apart from the theta's x. So that's good news. So we're looking at solving sine 2x, 23 cosine squared x, take away 8 cosine x, take away 15 equals 0, between 360 and, 540. So either sine 2x is 0, or 23 cosine squared x, take away 8 cosine x, take away 15 is 0. Okay, so sine 2x. Now, sine x has solutions 0, 180, 360. Okay, so that means that sine 2x has solutions 0, 90, 180, 270, 360, etc. Okay, so x is equal to 360, definitely, okay, plus, so it's going to have a solution every 90 degrees. So plus 90 would be 450, but remember, we're not having 450, so that's out. Plus another 90 will get us to 540, and so we have two solutions. So that was an awful right-hand bracket. Let's try it again. Oh, not too bad. So 360 and 540 are the two solutions for sine to x is 0. Okay, now we've got a quadratic and cosine. Let's pop that into the quadratic solver. So 23x squared, take away 8x, take away 15. And we get, so this factorizes to 23 cosine x plus 15. Cosine x take away 1. So cosine x equals minus 15 over 23, or cosine x equals 1. Now the cosine curve looks like this. So cosine x equals minus 15 over 23. So if we solve and do arc cosine of minus 15 over 23, we get 130.7. And the other solution is 360, take away that, which is 229.3. Okay, now both of those are outside the range. So if I add 360 to both of those, I get 490.7. That's inside the range. Sorry, x is 490.7 degrees. And if you add 360 to the 229, you get 589, which is outside the range. So we're only going to get one solution. Don't know why it's doing that. Not playing ball to me today. Here we go. So there's only one solution for cosine x is minus 15 over 23. Cosine x equals 1 will happen at 0. It'll happen at 360. Okay, we've already got 360. And the next one will be 720, which is outside the range. So we have, so therefore, the solutions are 360, 490.7, and 540 degrees. And they're the three solutions I'm looking for. So this is question number 15. A student attempts to answer the following question. Given that x is an obtuse angle, use algebra to prove by contradiction that sine x take away cosine x is greater than or equal to 1. The student starts the proof with, assume that sine x take away cosine x is less than 1, where x is an obtuse angle, which implies that sine x take away cosine x all squared is less than 1, which then implies ... The start of the student's proof is reprinted below. Complete the proof. Okay. So, my first instinct, any time I see sine x take away cosine x or two trig functions like that, added or subtracted, I immediately think harmonic form, and to write it in our sine x take away alpha, but I don't think I need to. I think probably it wants me to expand the brackets out, so I reckon I'm going to go that route. So sine squared x take away 2 sine x cosine x plus cosine squared is less than 1. Now, sine squared plus cos squared is, of course, 1. And if I subtract the 1 from both sides, and then divide both sides by minus 2, that, of course, flips the direction of the inequality because I'm divided by negative. So sin x, cosine x would have to be greater than 0. Now, sin x looks like this. Now, where the angle is obtuse, that's between 90 and 180, and you can see here that it is positive. So sin x is greater than 0 when x is obtuse. And cosine, when we've got an obtuse angle, is between these two values, and here you can see it's below the x-axis, so it's negative. So sin x, cosine x is negative when x is obtuse, not positive. This is a contradiction. Therefore, sin x take away cosine x is greater than or equal to 1 when x is an obtuse angle. Okay.